In this video, we will be looking at like terms. So like terms have the same variables and exponents. If we look at like terms, let's say we have x squared and 3x squared. So these are like terms because they have the same variable x squared has x, and 3x squared has x, and we have the same exponent too. Another example of like terms would be negative y and 7y. So we still have the same variable y, and of course these are just raised to the 1. So we have the same exponent and variable. That means these terms are like terms. If you had something like xy and yx, these are also like terms because we have the same variables, and of course we'd have the same exponents. They're all raised to the 1. And even though these variables, they're in different orders, we still get the same product because that's how multiplication works. If you have something like 5 times 4 or 4 times 5, it still gives us 20. So xy and yx would still give us the same products. They have the same variables and they have the same exponents, so they're like terms. Even if we had numbers like 2 and 3, these are also like terms because we still have these variables and exponents x to the 0. And since we know these give us 1, we still have our like terms because x to the 0 and x to the 0, they're the same thing. So these are of course like terms. Now let's look at some unlike terms. Let's say we have a and b. So a and b would of course be unlike terms. They're not like terms because they're two different variables. If we had something like x squared y and xy, these are also unlike terms because even though we have our variables x and y, we have this exponent 2 here, and of course this would just be x to the 1. So now we are going to be looking at how to add and subtract like terms. So in our first example, we have 7x, and we're going to add this to 4x. So we have our like terms since they have the variable x and they're both raised to the 1. And to add these like terms, we have to add our coefficients, 7 and 4. So that's 7 plus 4, and that's 11. And of course, we have our variable x. So that gives us 11x. If we do this with subtracting like terms, we have 7x minus 4x. And again, we have to look at our coefficients 7 and negative 4 here. And we're going to be subtracting them since we have our negative sign here. So that's 7 minus 4, which is 3, and our variable x. So we've added just the two terms here. We have our like terms, but what if we have an expression that we have to simplify, and in this expression they're not all like terms. We have some numbers, we have some variables and coefficients. Let's try that. Let's see, we have 3 plus 2x plus 5 plus 4x. So we have our like terms 3 and 5, and we have our like terms 2x and 4x, which have the same variable x. So we just collect our like terms. We combine the terms that are alike. So that gives us 3 plus 5. These terms are alike, and plus 2x plus 4x. So that gives us 8 plus, and we know that 2 plus 4 is 6, so that's 6x. So our last example of this video here deals with a lot of terms, and we have to use the same strategy where we basically combine our like terms. So if we look at each term, here we have 3x minus y plus 6z minus 7 plus 4y minus 3z. So if we look at our first term, we have 3x, and we know that there are no other like terms here because no other term has the variable x. So we just write 3x. Our next term is negative y, and we know that this negative y here has the same variable as 4y, and they're both raised to the 1, so we can write them out as like terms. So it's negative y plus 4y. And we have 6z here. So if we look at all the other terms, we have this negative 3z here. And since these have the same variables, we can combine them. So that's 6z minus 3z. And of course, we have this negative 7 here. And there are no other numbers here, so we just write negative 7. So now this gives us 3x minus y plus 4y is 3y, so that's plus 3y plus 3z minus 7. So that concludes today's video on like terms, and in our next video we will be looking at the distributed property like I said earlier in this video. And if you have any questions, please leave them in the comment section below. Thank you.